All right, I know we all love rational functions, but sometimes we can use this section for functions that are not rational functions. Wow, how exciting. Let's see that in action and get a little bit more practice. Integral of cosine of x divided by sine squared of x minus sine of x. Okay, so right off the bat, something that jumps out to me here is that if u is sine, we have that derivative. A u substitution is looking pretty good. Think of other things that we could use. Integration by parts, not really good. There's a trig identity. We could make sine squared be 1 minus cosine squared. That's not good. We could use the reduction formula, make sine squared into a cosine of 2x. That's no good either. Think of your options though. Before starting, it's a really good idea to think of your options. U substitution's looking like the best bet here. Because it'll make things look a lot nicer. We can get rid of the sines, we can get rid of the cosine, and we can just get things in terms of something else. So if u is sine of x, again, we're choosing sine of x because there's quite a bit going on with sine, and we have its derivative right here. So a u substitution, we have that du. So du is going to be cosine of x times dx. So this just becomes, again, this is our du right here. This becomes 1 over sine squared is u squared. Minus sine is u. And then this rest just becomes du. Oh. This is close to other things. Well, we can't do a u substitution. Integration by parts is not really going to help us. This isn't any inverse trig functions. We're going to use partial fractions. Where is the degree on the top at least as big as the bottom? If so, we're going to long division. It's not. We're going to have to decompose it. So specifically, we're going to say, all right, let's look at the denominator. How do we factor it? Well, it's going to be u times u minus 1. Oh, so what we know from partial fractions, those are distinct linear factors. So then our whole rational function is just some constant divided by the first one plus some other constant divided by the second factor. How do we find this factors? Multiply both sides of the equation by the LCD, u squared minus u, which is the same as u times u minus 1. And when we multiply that all out, we get 1 is equal to a, the u's cancel, plus b, the u minus 1's cancel. We can use both methods. And in fact, I'm going to use both methods just again to show them. So the first one is going to be systems of equations. I don't remember what I call it. Equating coefficients. So the u terms, there's no u squared terms. So the u coefficients have to be equal to each other. On the left, there's a 0u. On the right, there's an a times u and a b times u. And again, there's really this intermediate step I'm not doing. 0u is equal to au plus bu. This has to be true for every u. That's why 0 is equal to a plus b. That's what's coming here. That's where it's coming from. All right, and then we also have to look at the constants. Well, there's a constant of 1 on the left, and there's a negative a on the right. Oh, that's it. That's the only constant on the right, just a negative a. So a is equal to negative 1. Well, that tells us that 0 is equal to negative 1 plus b, or b is equal to positive 1. Oh, that's great. We're done. We could check our answers. I'm going to check our answers by actually doing the other method. Strategic substitution. Well, we know this has to hold for any u, so it should hold for u equals 1. What happens if u equals 1? We get 1 is equal to 0 plus b times 1. B should equal 1. That's what we had. Should also behold, again, I chose u equals 1 because we had a factor and it'd cancel out. Choosing u equals 0 because we have a factor and I'm hoping it cancels out. So that'll give us 1 when we plug in u equals 0 equals a times -1 plus 0. Oh, so a has to equal -1. Great. This is consistent with our answer. Both methods, same result. Great. So that tells us that our integral, our original integral is the integral of cosine over sine squared, blah, 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 which is 1 over u squared minus u which we just showed was a, -1, over the first factor plus b, +1, over the second factor. And again, we could check our answer. If we combine fractions here, this becomes -u minus 1 over u times u minus 1 plus u over u times u minus 1. And when we add these together, we distribute that negative. Negative u plus u cancels out, and we're left with 1 over u squared minus u, which is exactly what we have. That's good. Now we use what we know about calculus. We get negative natural log of u plus the natural log of the absolute value of u minus 1 plus some constant. And then we remember that u is the sine of x. That's our answer. And we could check it. A couple different ways we could check it. We're not going to do it here. Yes, we're going to check our answer. Why not? This is the end of the video. Feel free to leave. Feel free to go. You don't have to watch this part. But if you want to see me check the answer, stick around. So if we take the derivative of this, that's going to be negative. Derivative of natural log is the derivative is 1 over the inside. Then we do need the chain rule. 1 over the inside. We do need the chain rule. Derivative of constant, 0. So this is negative cosine of x over sine of x plus cosine of x over sine of x minus 1. We need a common denominator if we're going to combine these. This needs a sine x over sine x. And this needs a sine x minus 1 over sine x minus 1. These denominators have no common factors. That's why we have to do this. So the top becomes negative sine of x minus 1 times cosine of x. This becomes sine of x times cosine of x. And the bottom is just that sine of x times sine of x minus 1. And we want to make this look like our other answer. So when we distribute, or we could just factor out a cosine of x. That would be actually really clean, because that gives us negative sine of x plus 1 plus sine of x if we factor out a cosine of x from everything. And then we want, normally we leave the bottom factored, but we want it to look like our answer. So let's distribute it. Sines cancel and we're left with just cosine over sine squared minus sine, which is what we wanted, our integrand. So it does check out. There we go. Those are the two methods. That's partial fraction decomposition. This is what we do if we have non-repeated linear factors. Do you want to know what happens if we have repeated linear factors? Stay tuned. Here it comes.